So as an AI student or professional, you're undoubtedly going through what you know about AI, particularly generative AI, as we are now on the cusp of AGI, artificial general intelligence. And just as though you were a bridge player looking at the cards in your hand and assessing, what do I keep, what do I discard, you might be looking at the knowledge that you've built up over probably years and saying, where am I strong? Where do I need to supplement? Where do I need to go deeper? And you are very likely saying to yourself, this isn't a skills-based situation right now. It's not about, can I learn more prompt engineering? I mean, if you do decide that you want that or similar skills, there are courses available that are anywhere from cheap to free. So we're not talking about that right now. Those are skill sets that have potentially a relatively short lifetime. But now you're after the depth, you're after the core, you're after the fundamentals, you're after what is going to carry me as generative AI, which is already an order of magnitude more complex than basic AI, becomes the foundation layer for artificial general intelligence. So you're very likely asking yourself, what do I need to study in order to read, for example, one of Jan LeCun's papers, especially where he's talking about nuances comparing generative AI to other methods. When he has a fairly detailed conversation, for example, about contrast of divergence, you want to follow that logic line and assess, is this what I need? Is this what I don't need? As I envision myself building an AGI system, you're probably looking at the new inference engines that are coming out. Some of them using very old-fashioned expert systems methods. Some of them using reinforcement learning bolted on top of a substrate that could be corporate domain knowledge or a large language model specifically with some materials introduced for a given corporation. So these are directions in which we're going. We're seeing the evolution over the next year, 2, 3 years maybe even, will have strong developments in the area of narrow AI, artificial narrow intelligence, if you would. This will be areas where AI is very specifically focused. It will be, of course, agentic AI. There will, of course, be some stacking of modules and capabilities that will be evolving some hierarchical capabilities. But still, all of these narrow agentic AIs are going to be kind of narrowly focused. Even so, that's the current wave, and building on that by adding in reinforcement learning, probably a good call. But underneath that, we still got that basic generative AI core foundation layer. You might be looking at your own knowledge and saying, where do I need to bolster what I know and understand? Hello, if we haven't met before, I'm Dr. Aliana Moran. I'm the founder and chief scientist of Themesis Incorporated. We are a boutique AI research company. We've got some fabulous developments that we're not even going to talk about right now. I'm the founder and one of the primary professors in the Themesis Academy. And let me just take a moment. We have this short course, Top 10 Terms in Statistical Mechanics. It's built to provide that essential core underpinning that contributes to your knowledge of generative AI. But that's not what we're about today either. What we're talking about is you. We're talking about you and generative AI, and how can you, particularly over this, since I'm shooting this in early December 2024, we've got this upcoming holiday season. How can you use these few weeks to build on that core so that as we move into AGI in the coming year, in 2025, you feel stronger, more confident, more solid? Now, as an important part of this whole conversation, I always introduce myself with a Themesis connection, but there's another round. For the past, ever since 2015 actually, I've been teaching artificial intelligence online through Northwestern University's Master of Science in Data Science program. I've developed 3 of their key courses. These are all required courses in the AI specialization. The first being AI and Deep Learning. Introduced that one in 2017, early 2017. It was special topics, immediately filled up, became a regular course in short order. I did a major renovation of the natural language processing course that we have. That is also a mainstay of the AI specialization curriculum. And then a few years ago, I developed a capstone specific for the AI people. So I tend to see all of our AI folks at one point or another, especially when they come into that final capstone moment. Let me tell you, their work is fabulous. It is so, I just did a read and review on 2 of their final projects earlier today, and I'm just so buzzed. I mean, extraordinary work, top tier professional capabilities. I'm always just blown away. Can't stop from saying how excited about the work that they do. But wherever you are, and this holds for my students as well, I haven't been able to teach them what I'd like about generative AI. I haven't been able to shoehorn that into the NLP class. I haven't been able to fit it into the AI and deep learning, in part. I've got to admit this. In part because it's taken me until now to develop curriculum materials. And prior to that, I had to teach myself generative AI, and that was a bumpy road. And it was a lot of diving into the theory across multiple little branches of generative AI. And I got lost and turned around and tossed upside down so many times. And my misadventures, if you will, are your benefit and your gain, because now that I've been able to sort things out, organize them, present some things clearly, you can pick up on this very, very fast, very easily. It is such a smoother road and an easier, more gentle and loving and happy experience for everybody. So what we're doing right now is we're introducing 12 days of generative AI. It's sort of a prelude to the Christmas season. It's a Christmas present, if you will. I mean, why not? It's just a fun way to look at things. And we're going to have 12 days. I'm going to try to shoot a little vid, just a tiny vid, lightly edited, not a tutorial, just sort of a light overview for each of these days, a little tiny bit of a blog post, and here's where the contribution comes in. I'm going to go through the materials that I've developed over the past year, actually past several years, and I'm going to cull best of the best from YouTubes, from blog posts, I've got some fabulous resources in the form of book chapters, in the form of some white papers that will really help bolster your knowledge and get you through some of those tight spots in what I've come to call the Donner passes of generative AI. That's where we've got this imaginary journey over the Sierra Nevada mountains where you're crossing over, and everybody's got the prairie country stuff down just fine. The Great Plains, so to speak. We all know backprop, we all know CNNs. Most people have at least a rudimentary understanding of reinforcement learning. And then when it comes to the generative, that's actually up in elevation. The abstraction is more complex. It involves 3 different disciplines interacting. It's the convergence, and this is the tricky part. It's the convergence of the reverse Kullback-Leibler divergence method, Bayesian conditional probabilities, and just enough statistical mechanics that if you haven't been given a good introduction, it makes your head spin. But if you get a good intro, and I'm saying 2 weeks is all you need, 2 weeks, and that's 1 week of thermodynamics, and this is part of the short course, the top 10 terms. 1 week of light, gentle, easy thermo, just to introduce a little bit of notation and vocabulary. Then the second week is where we do stat mech. You get through that second week, and I've got videos and tutorials and all kinds of support material there, and you've got this thing nailed, and you can go back and read some papers that earlier they were just not possible. But let me get back on track here with the 12 days of generative AI. Some materials that are in that course I've also made public as YouTubes, or they are reading materials on the Themesis website. We can point you to that, and you can build your own course. And if there's anything that's a message from what I'm saying to you today, you can build your own course. It'd be lovely to enroll in a $5,000 course in this topic at Northwestern. You don't have to. And until we build this kind of a course in Themesis, where we can work together and I can be with you in, say, fairly frequent sync sessions, as we call them, online Zoom meetings, and I can answer questions, and I can actually give you homework and get it back from you and give you feedback. That's so important, closing the loop. Until we're there, you can self-study. You can get so on top of so much. So that's what we're talking about today. Today is our intro, it's our overview. Keep in mind, 3 basic fundamental capabilities that fuse together to create generative AI. Once again, the reverse Kullback-Leibler divergence, not just the regular, the reverse. You compare the data against the model. Then Bayesian, then StatMech. Put the 3 together, you've got the core of generative, all forms of generative. Also, just note very briefly today, there are different kinds of generative AI. Everybody says transformers, of course, yeah. And of course, when you read that original Vaswani et al. 2017 paper, it's a recipe. It doesn't take us out into the theory at all. It's a very straightforward description of how do you build the components. So that original paper doesn't go deep. A lot of the articles that you might read about transformers, and many of them are very, very good. Let's just say, the standard typical medium.com article, here's another transformer tutorial. There are dozens and they are good, many of them. But they don't make that connection down to what makes this generative. They don't get you down into the 3 elements that I just mentioned. And that's why a lot of people will say, okay, I know this is generative, and I sort of have a sense because we're doing probabilistic generation, but I don't see how it connects to the Boltzmann machine. I don't see how it connects to variational autoencoders. I don't see how it connects to variational inference, and that's what we're after. So please join me in the description box for each of these little vids. I've got a link to the associated blog post. The blog post has links to the goodies that are relevant and useful, specifically chosen and curated for you today. So thank you. It's been a great pleasure to have a moment with you once again. Aliana Marin from Themesis. Have a lovely day.